Hi guys, I am Ashwini Shankar and you're watching This and That. So today we will be talking about the automotive relays. What? Automotive relay? I've heard that somewhere. What is automotive relay? Basically, automotive relay is nothing but a controlled way of channelizing power from your battery to all the components that you need. Let's see how it works. Let's see how it looks and explore more about it. To start with, the automotive relays come in two types. One is a 4-pin relay and the other one is a 5-pin relay. I'll tell you the difference between these two. There is very subtle difference. There is only one minor difference. This is a 4-pin relay, this is 5-pin relay, and both of these work in a similar fashion. Along with these comes a micro relay or a mini relay. You can call it as mini relay, micro relay, or however you want. So these are also called the horn relays. These are especially designed for horns and other stuff. So I'm going to use this for fog light in my vehicle, but this can be used for all other purposes. I'll tell you the working principle about this. You can see the diagram coming up over here. So in this diagram, I have explained what are the terminals we have. The terminals on a typical 4-pin relay are 30, 80, 85, 86 and 87. So this is a general numbering. This number never changes. 30 always goes to the positive of the battery. 85 or 86, it goes to the ground, that is negative of the battery. And whichever the other terminal, if you have grounded 85, you can give 86 to the switch, or if you are grounded 86, you can give 85 to the switch. And then the 87 goes to your component. It's confusing, right? I'll tell you how. So practically, if you see this, 30, the power comes into the 30 and it goes out to your component on 87. But there is no direct connectivity for these two. There is a link between these two and these two. So there's a coil inside this. The moment you pass power between these two, the electromagnetic, whatever the electromagnetic induction happens, that will pull the coil between these two into one part. So it is apart. The magnet will pull the coil, pull the plate together. So once it connects, the power goes from here to here. So this is just a switch. This requires very minor current. Even a 9 volt, half an ampere or 500 milliampere will work. But the main concept is you are passing current from here to here and you are controlling the current flow from here to here through this. How it works? Let's see. To connect this, you need thimble, you need good quality wire, you need multiple colored wires so that to differentiate which is the positive, the wire that is carrying the positive current, the negative one, and the one which goes to the switch. You can differentiate with the wire so that you never get confused with this. Again, these are called thimbles, which in turn, when it is connected to the wire, it gets connected onto your terminal like this. Please do keep something in mind. See, these are a 10 rupee thimble. You can see the quality over here, and these are the 5 rupee thimble. You can see a considerable difference in the quality. So choose carefully. Everything matters. The conductivity, the way how it behaves, the loss, everything matters. But for a low variation, I'm going to use this on whatever wiring I'm trying. I'm using this on a parking light. So I am not very concerned about how good quality metal it is, but definitely I would recommend go with a higher, better quality and avoid these kind of thimbles. And also to connect this, you can see my circuit diagram that is coming up on the screen. And before you connect this, I would recommend don't connect this directly to the battery. Always use a fuse to connect this with the battery. This is called a blade fuse, and to hold this, you need a blade fuse holder. So if you basically see this, this just has a fuse. I'm using a 30 amp fuse. I'll tell you why. And the other one, I'm using a 15 amp fuse. There are two fuse holders I'm using with two fuses. One will be for the input. I'll be connecting this to the battery and then to the 30. So while coming, the input, this is regulating the power. If anything exceeds 30 amperes, the fuse will burn off, but your relay stays the same. Your relay costs anywhere between 120 to 140 rupees, but your fuse costs about 5 to 10 rupees. So that's the difference you have. That's the reason why we use fuse. Fuse is basically a circuit breaker when there is an excessive current. And also, while you give it out to the components, always use another fuse holder with the fuse, so that if there is any excess current that's going from the relay to the component could be a bulb, could be anything, that will not get spoiled, that will be intact. So always use an output fuse as well. So I'm using two fuses. I'm using a 40 amp relay. So I'm using 30 amps as an input. Always use an ampere rating that is less than your relay, so that whenever there is an excess current, this will stop. Also keep in mind, while choosing a blade fuse holder, you always choose a ceramic holder, because this is going to get heated up a lot. It is going to carry a huge current. This will get heated up, and when it gets heated up, this is ceramic holder. This is going to hold a lot of heat and helps in the longevity of this fuse. So always make sure you're using a ceramic one. And this is my input. I'm taking a 30 ampere fuse, and for my output I'm taking a 15 ampere. Now you may have seen the 30 ampere was in green, 15 ampere is in blue. These color codes never changes. So let's keep it aside. Let's bring in some fuse. So if you see this from the left, this is your 10 amps, this is your 15 amps, this is your 20 ampere, this is 25 ampere, and this is 30 ampere. So the color codes never change. The red is always 10, blue is 15, yellow is 20, white is 25, green is 30. So always keep in mind, whenever you see the color, automatically it should tell you what ampere rating it is carrying. And also, to connect this to the battery, you might also need this. This is basically another thimble which connects to the battery terminal. And there are multiple types of batteries where you might also have a long connecting pin that carries a different one. And to crimp all these, you will need a crimping tool. So this is a crimping tool. This is how it looks like. So basically these are the holes where you can go ahead and add a thimble and crimp it out to the wire. If you don't have this, even then that is fine. You can simply take a plier and start crimping them. I'll show you how. I'll crimp one of them and I'll tell you how this is done. So let's keep everything aside. So this is wire stripper plus crimper. I'm using a lot of crimping, so I have this. You are getting this in Amazon. I'll leave the URL in the description. I bought it up at around 570 or 580 rupees. I don't remember, but this is within that range. And to crimp a wire, you need just the plier, and to peel or skin off the wire, you need scissors, or even if you have a plier, that's absolutely fine. So I have already added a couple of ones, like I have a fuse holder, right? I'm going to add a 30 ampere to this. Like if you see this is again a ceramic fuse holder. I'm adding a 30 amp fuse to this. This is 30 amps added. I already have this crimped, and I'm going to use this to the positive of the battery that is coming from another wire, and this is going into the 30 of the relay. So now I'm going to just connect it to the 30. This will go into the battery. Now I will also have another wire So this wire will go into your device, whichever you want to turn it on. This will go from 87, you can see this is 87, and this from 87 will go all the way out into your device. Now the connection from your battery to your device is ready, but there is a circuit in between you will have to connect. Always connect one end onto your battery negative or the ground of your vehicle. So I also have another one. I am going to connect this onto the battery. So I have this at the end of the terminal. So connect this over here. So I have 3 terminals ready. For this, what I'm going to do is add a switch so that whenever I turn it on, the device turns on. When I turn the switch off, the device switches off. In reality, before the switch, you will also have to run it through your on and off switch, so that the switch only works when the key is put and the ignition is turned on. Otherwise, even while parking somewhere, somebody can go ahead and just turn it on. So let's see how the switch works in between this and this and power on the device. We start with the connection. I would like to show you how to crimp a thimble using any tool. So I have used a plier to just skin it off. You can use a plier or a scissors, whatever you are comfortable with, and then you need a thimble. So it's pretty simple. You are going to keep it here and then close these 2 terminals with each other and these 2 each other. So I'll show you how. I'll bend it a bit so that it becomes a little more thick. And guys, I'm demoing it with 1 square mm wire, but I'm going to use 2 to 2.5 mm square mm wire. So please do use a higher quality wire, otherwise there is a risk of short circuit, or the wire might even go burned, like it will melt down. So if you don't have a crimper, all you have to do is you have this, right? So just press this from one side, this will start bending. So this went through, it is now sitting on the wire, and then press the other side. So now it is holding the wire very strongly. If you see this is holding the wire very strongly. There is now this part left over. Press it from one side, it closes off, and then press it from the other side. Now this is complete. This will not come out. Press it hard, this will not come out. The advantage of having a crimper is very simple. It does the same thing. You just have to find the right one. I'll have this socket. If you see here, the wire is held, but it's not as tight as what a crimper can do. So I keep it here, right? I put it here and then press it. Press it hard, release it, and now you can see this is totally done. Like there is no way that this can escape out. This is like rock solid. Now you cannot leave it as is. Either you'll have to do a taping or you have to use a heat shrink. So this is how a heat shrink looks like. This is just a pipe kind of a thing. So what I'm going to do is I'm going to take a scissor, cut it out to the size of what I need to add it up over here. So I need it till the end of this. Take a measurement, cut it a bit more than that. There it goes. Oh my god. So I have it ready. This is slant. I'll make it straight. That's all. I have my heat shrink ready. Either you can insert it from here, or you can already put it from the other side, or keep it ready even before adding this thimble. So this is a 5mm heat shrink that I'm going to add it up over here. So this is going to help me in insulating this in a better way, and it also becomes more of waterproof from one side. Other side definitely it will be open, it will not be a waterproof. But on the other cases, right, when you do a heat shrink, that will become kind of waterproof. So I'm just pushing it into this. It has reached to the corner of it. Now you see this is all big and fluffy, and this one, there is no use of it. How heat shrink work is, the moment you apply heat onto this, that will shrink and get attached to the kind of like the curves of the body of whichever the surface it is covering. So either you can do it with your hair dryer, or you can use a lighter or kind of thing. So let's try this out. So if you see, this will not burn, it will just shrink. It shrunk. This is all. So this gives excellent protection, right? This also helps this not getting touch with the other leads and terminals in your relay. So how the relay is connected is pretty simple. When you have this, you just have to connect this like this. So I'm connecting this to the 86 so that I can add a switch to this just for the demo purpose. This is my 86, and while adding, I already have added thimble and the connectors onto the wires. This will go to my battery negative, so I have this, and I'm going to give this onto 85. This is going to be the ground. So this is added up, and then finally comes the output where this goes to the device. So this is going to be my output to the device. This is all clumsy. I'm just showing how the wiring is done for the vehicle. So this has longer wires. I'm going to show you with the shorter one, which much more cleaner version, right? I'm going to insert it over here, and then the input always use a blade fuse holder. As I said, you can see the color over here. You can see whether the fuse is intact or not. There is a connectivity that can see through this hole. That's why you have this. And if the fuse is gone, it is much visible. I want to tell you another thing. If you connect more than one fuse, right, the blade fuse holders do have a mechanism of interlocking. So this is my 15 amp and 30 amp fuse. If you see, there is blue, there is green. Blue is always 15 amp, green is always 30 amperes. So now if I have to use these two, this will be like dangling around, or I can do is you just put one below the other like this and close it. There is a holder here that can hold this, that can slide into this. So now these two are together. You can bundle it, you can add it up with that, you can put a tie around this and make it firm, and then use this connection based on that. My suggestion is don't use the same colored fuse holders for both of them. You might get confused. There are multiple colors available with each of the company, whether it's Super, Vaishnu, or any other company, right? To that matter, Uno, Minda, or anything. So use a different colored wire for both of them. Unless like you go see this is green, this is blue, don't do that. I would say go for a different colored wires for these two. Now what I have done over here with my connection is I have already added a thimble to this, and to the connection I am going to add this onto the 30. So now what happens, I'm going to give this to the battery. So whatever the power comes into this will be from 30. This is again a ground, 85 is ground. Okay, let me remove this, and this will go to your switch, and this will go to your device. Let me remove all of these. Let me make it clutter free and show you within ease. So for now I'm using a DC power, so I don't need a fuse here. I know how exactly it is coming up and where exactly I have plugged it in. So all I'm going to do is give a 30 onto this. This is a positive one, and then I'm going to give negative onto 85. Now let's say this is my device. Let's consider this as my headlamp. Very ideal to use it. it will not prick in the eye if I put it like this, and it also has a wire, so it becomes easy for me to hook it up over here. I'll hook it up and I'll continue. Your negative terminal runs throughout your battery, throughout your chassis, whatever you call it as, the body of your vehicle, and then the positive should go to 30. The power from 30 will flow through 87 to your device, and this is just a switch. So the moment you do the give the power through any of the switch or any of these, this will light up. Let's say, let me remove this and let me show you a switch. I have a switch here, but I don't have a connector to this. Let me try and insert it over here. I'm inserting this into this. I just need some conductivity, that's all. So this goes into this, and then this lies with this. Now when I power on, this is on. When I power off, this is off. So this is basically your switch. But never give this directly onto your battery. While even standing, anybody can operate your whatever fog lamp or headlamp or whatever it is. Always give from battery to your on off switch, and then from that switch give the power onto your current fog lamp switch. So this is going to handle everything else. So this is all a relay is about. And finally, before we wind off, the 5-pin relay is exactly same as a 4-pin relay. It has 30, 85, 86 and 87. But along with these 4, there is one at the center which is called 87A. So what's the difference between this and 4-pin relay? This 87 behaves exactly like 4-pin relay. So the power comes from 30 to 87, and 85 and 86 are basically the switches. But 87A acts as a reverse one. Like whenever this is off, the switch is off over here. This conducts, this gives the electricity out, 87A. And when this turns on, when the switch is turned on, this goes off and 87 starts conducting. So let's see a demo out of it. So if you see, I have not connected the switch over here, but my DRL is running. Let's say I'm going to connect the switch from here to here. My DRL is off, headlight is on. DRL on, headlight on. So it's just a flipping circuit. So 87A basically is the opposite of 87. Whenever 87 is off, your headlamp is off, your DRL will run, and whenever the headlamp or the fog lamp turns on, the DRL can be turned off. So this is the main advantage of this. So this is just about 87A. You have any concerns, any doubts, please comment in the comment section, or else even if you want me to redo something, or if you want me to take a look at something, please comment. I'll try to reply as much as I can, and I'll also answer as much as I can. So this is all about relay, the theoretical explanation of this. I will do an installation of this on one of the scooters. I'll show you the practical one in my next video, but for now, that's it. Please don't forget to subscribe, like and hit the bell icon. And with this, I am signing off. Ashwini Shankar out. Thank you.